Dmitry Alexandrovich, hello. Tell us please, what makes the Slavyanka motors different from Tesla motors in terms of the technology and comparative performance features? Thank you. The company Tesla uses standard winding. We use combined winding. In terms of the performance features, we haven't rewound Tesla motors. But the fact is, if they are modernized using our winding, they will be just as different as the general-purpose industrial motors rewound using the combined winding technology. Because this solution can be applied to all induction electric machines with a short-circuited rotor, so the same effect will be achieved. Because the Tesla motor does not differ in any way from a regular, general-purpose industrial motor. The only two main differences are that in industrial motors the squirrel cage is wound, or more precisely not wound but filled with aluminum, and they use copper for their motors. Why is that? The fact is that copper winding increases the inrush current. And the multiplicity of inrush currents there is crazy, whereas the starting torque is low. If you apply this solution for industrial motors, the motors may not start under load. Increasing the resistance of a squirrel cage due to using aluminum reduces inrush currents, but at the same time, it allows to increase the starting torque. So, this motor is not applicable as a general-purpose industrial motor. At the same time, the copper winding increases the multiplicity of the maximum torque, and the maximum torque is a great significance in a car, because due to the maximum torque, the multiplicity of the maximum torque, we also get bigger starting torques at the start of a car. This is why a squirrel cage is made of copper for drive motors. But we now make drive motors from general-purpose industrial ones and ensure quite high performance characteristics. If we also use copper, the performance will be even better. On top of that, Tesla motors are water-cooled, unlike general-purpose industrial motors, which are air-cooled. To be honest, I would not say that this is an achievement. In my opinion, water cooling in electric motors, the type that is used there, is too clever by half. I have already said that it would be easier to put the following system there. Take the air conditioning system used in cars, but this is the air conditioner reversed. You put the cooling system on the motor, a steam compressor will cool the antifreeze, and the hot side will be air-cooled. And then you will have 120 on the radiator, and the motor will be plus 15. And now it is 80 on the radiator and the motor is 120. So in fact, this solution makes it possible to increase the operating temperature range in which the car operates comfortably, right? Not only the range, but also to reduce losses the motor incurs. Do you think we will overdo Tesla in terms of the motor quality? We did that a long time ago. Look, Tesla demonstrates 110 watt-hour per kilometer in the best case scenario, and 170 on average. And Igor Korhov's Elada with our motor demonstrates 46 watt-hour per kilometer under the same driving conditions. You mean the consumption? Yes, this is electric energy consumption. Is data for different driving models also available? No, this data is for the same moderate load mode, normal driving mode in the urban settings. It's not like pedal to the floor and to the limit. No, because there are other capacities, other types of cars, transmissions, solutions, and so on. But nevertheless, that's a fact. Currently, some materials are being prepared. I think as soon as we can, we will post the efficiency map on the website. A three-dimensional nomogram, the dependence of efficiency on the revolutions, and motor speed of rotation. We invite Tesla to publish similar data. What a twist! No problem, let's see how our motors compare.